Today I'll be talking about enabling developer-led infrastructure as code. So, yes, my name's James D'Alfonso. I am the cloud product owner for GCP, and we are, in the platform team, the enablers of cloud adoption and providers of an automation framework as a vehicle to get us there. So today I'll be talking a lot about GCP, how we establish our platform, and how we use Terraform Enterprise and Vault in the mix. So I'm working at Erste Digital, and Erste Digital is part of Erste Group, which is a group of banks operating in Central and Eastern European countries. So we have over 16 million customers, and Erste Digital is an IT provider within the group. So we are primarily based in Austria, so the headquarters is in Vienna, so that's where I sit. So we are over 2,300 employees, and just to give you a nice idea of scale of our applications, we manage and run over 1,300. The cloud standard, abstracting away the complex with a unified process and language to unlock the cloud. So we think that cloud presents an opportunity to change organizations, how you view your IT landscape, and culturally as well, and really change your IT landscape. Now, the standard pattern for large enterprises is to establish a landing zone. So of course, we're no different. And a landing zone is there to support workloads. A landing zone itself delivers no value without workloads, and that's where we need to ensure that we can scale, firstly to accommodate those workloads, and we need a process and way for those workloads to transition into the cloud so that we can maximize the value and drive business value through these workloads. And this is our challenge as the landing zone team to ensure that we can meet this challenge. We need to scale, and we need an easy way to scale as well. So I think the term ClickOps has been mentioned today a lot, and there's a lot of parallels with the previous presentations, I have to say. So really enforcing some lessons learned, I think. So what we don't want is ClickOps, maverick deployments. We don't want a chaotic environment, which is represented there on the left, where we have single points of failure, confusion, stressed employees. We can't have that. We want a good operating model. We want stability. We want standards, and we want to keep our environment clean and maintainable. So we want to introduce code as a common language for our developers and our engineers in our journey towards the cloud. So with this in mind, when we're trying to establish a landing zone and transition into cloud in the context of GCP, one of our first problems, so we started this journey roughly 3 years ago, and we identified this issue of process fragmentation. And it's actually what we discussed on the table as well over there. So what I have represented in blue is different workloads, and these little blue icons are services they consume. And then we have our developers in green that will develop these applications, these workloads. Now let's introduce a fragmented process. So we have our infrastructure experts who have different ways of managing these services. So initially, when we started our cloud transformation journey, we had a limited service catalog. So we start with the most important services, storage, database, so that we can enable the majority of our workloads. Most of them need that. So that's okay if we have some process fragmentation there, only 2 services, okay. But as we introduce more services and more process fragmentation, issues start to appear. It gets increasingly hard for our infrastructure experts to manage it, to link these services together logically, and it puts a lot of cognitive load on our developers in order to get the right requests in the right format. How do they do this? How do they put it together? So this is where a unified approach comes into play to managing infrastructure in the cloud. At the beginning of our cloud transformation journey, we decided we would have a common automation framework to managing our cloud infrastructure. And it was a really important choice for us. And we said, if you want to go into GCP, this is the way. So, and it was a great start, but there are still some problems that we identified early on. So even with this unified approach, what we noticed is that our service request layer was struggling to keep up. So we expand our service catalog. We start with storage and database, and we expand our service catalog. And what we were noticing is that we have services that are technically enabled on the platform, but not requestable, not consumable for our developers. Why was this happening? Because making good service request forms that are easy to consume, that make sense, and integrate them with the automation framework is very difficult. So I'm sure there's people in the room who have really tried. So for us, it's ServiceNow request forms, and it takes a lot of effort to make very good request forms. And so as we noticed that we couldn't keep up on this layer with our service enablement process, which then blocks workloads and blocks value from the cloud. And this is where we get to self-service for our developers. So what you'll notice here is we have these two teams now that want to manage more complex workloads. So an example of this is our data platform team, where they consume data services like BigQuery, Bigtable, things like that, Composer, Dataflow, all these more cloud-native services are going to start using GitOps. And so we have introduced a new operating model, and service requests still have a place here. But with GitOps, we empower our developers to have independence and ownership of their cloud build. They are able to interface directly with the automation framework, and they don't need to wait for anyone. We see roles change as well for our infrastructure experts. So infrastructure experts become more like consultants and providers. They talk to developer teams and work with them to build their environment, providing expertise advice, and also providing reusable modules and code to accelerate their onboarding as well. And through this, we establish a community. We have more people working in the same way and writing the same kind of code, speaking the same language. And our developer teams start to become the multipliers. So we can multiply the speed and get there faster and onboard more workloads. Service requests still have a place. So GitOps doesn't suit everyone. Not everyone is ready to start writing Terraform code. That's fine. Not everyone has to do it. Service requests still have a place for what we found is more simple requests day to day. And they're still an important piece of what we do. And actually, there's something coming up later that I'll show we use service requests in this context. So they're not gone, but we've just reduced the pressure on this layer by introducing different ways of working. And if we zoom out even further, so I'm talking today mostly about how we use this for GCP, but actually this GitOps approach is used much more broadly in Erste Digital. So we have a multi-cloud environment. We have all three, GCP, Azure, AWS. So we're using the automation framework and GitOps for all three providers. We're also using it for Cisco ACI on-prem, and our use cases continue to grow. But the point here is we can see now our developers and our infrastructure experts are working on the same layer in the same way. And this is working quite well for us to scale and increase how we use our automation framework. So I've talked a lot about the automation framework. Terraform Enterprise is at the heart of everything that we're doing. It is our infrastructure as code tool of choice. And we leverage quite heavily off its enterprise features like the module registry. This is where we provide reusable blocks of code, abstraction there for our consumers and everyone to use. We have Sentinel policy in the mix to add a layer of governance at this layer. And also you onboard teams to use it, and so you have a central platform for to consume Terraform Enterprise. It is integrated, so our ambition is to do everything as code. To do everything as code, you need repositories. So for us, that's Bitbucket. And using Vault Enterprise as well for the dynamic credentials. So we saw a lot about the integration, so thanks, David, for the presentation today. We have a very similar setup in there, so his is more detailed, of course, and what I'm going in today, but it's a very similar setup where we use, OADC, JSON Web Tokens, and stuff like that in there as well. So, and another common pattern I think I noticed today is that everyone seems to be managing Terraform with Terraform, Vault with Terraform. And this is a very important thing to do in order to scale automation frameworks and your cloud environments as well. So definitely a pro tip there, I think. So 3 years ago, we started in the platform team with 10 people. And now we have 280 developers using this, or infrastructure experts. So, and these Terraform providers are the use cases that we have, that we're managing. And this is continuing to expand as well. This is not all we're doing, but they're the main players. So yeah, over 1,000 workspaces, 165,000 resources under management. So it's really, it's really expanded, and it's really an industry standard. There's nothing special with actually what we're doing, but it shows industry standards work. They're there for a reason, and yeah, if they can work at a bank, they can work everywhere, really. So onboarding developer teams to the automation framework. This is a challenge. So you're going to ask a developer team to write Terraform code. They'll be new to Terraform, probably. They might be new to the cloud, and they don't know internal standards for both Terraform Enterprise and the cloud standards as well. What are the platform standards? These are big barriers that we need to help them as infrastructure experts to understand so that they can become self-service and self-reliant. We're also going to give them, we're allowing them to do GitOps, so they're going to have flexibilities and powers to manage their own infrastructure. So we need to balance flexibility and governance. It's a non-negotiable for us. Things must be secure and they must be compliant. But we need to address the speed. We need to onboard them, of course. So to handle this is where abstraction, modularization come into play. And finally, a term I'll be using is productization. And we use these to streamline this process to get developers onto the automation framework and consume it. So we need to give them modules that they can reuse, processes that are easy, so that they can start building their cloud environment. This term productization comes into play here. What it is for us is the combination of multiple Terraform providers that are logically grouped into something useful, something that solves a problem. The problem that this product here, which we call the GCP project product, solves is a developer team who say, I want to manage my cloud environment in GCP with my 6 services there in blue. I want to do it independently, I want to do it with Terraform, and I want to write infrastructure as code. They do a service request, so this is where service request comes into play. And they say, these are my 6 services. This is how I identify my workload. Give it to me. And within a day or so, the service requests are automated, of course. They are independent and they are enabled, technically speaking, to do this. And We have, at the moment, so just in the context of GCP, we're using this product, of course. So there's 19 teams who have used this product, and that represents 84 developers, and they're managing 49 different workloads in the cloud. And it is used heavily, 41,000 Terraform resources. So yeah, those who are using Terraform Enterprise know how quickly they can go up, but it's used very heavily. So it kind of shows the success of this approach as well. And we started, putting it in a timeline, we started 3 years ago establishing the landing zone, and 2 years ago when we started introducing this product. The first consumers of the products was our data platform team. They had more complex setup, more complex needs, and so we needed to think about how we could address their needs, and this is where it was born. So what is this product comprised of? I call it 4 different pillars. So the first one being probably the most important part is the GCP project. This would be in AWS, the account, where we create a project for them. They said they wanted 6 services, so we enable those 6 services. These are compliant services from our service catalog, so we enable those. It's integrated into the landing zone, which means private networking, security frameworks, security perimeters, things like that. And we also do IAM for it, so we create an account that has permission to manage their 6 services, but only their 6 services. And this is important because we need to ensure that they can't do more than they should, and they only manage services that match their context and that are compliant as well. So our ambition, everything is code. To have code, you need a repository. So we create a repository, and this is where AI comes in our process. We can't talk about cloud and these days without mentioning AI. So yes, here we go. We create a repository, but not just a blank repository, but one that's initialized with AI-generated code that takes context from the 6 services that they requested, our landing zone standards, and our Terraform Enterprise standards. And this is like just starter code that helps them accelerate their onboarding into the automation framework and understanding how to build their environment. And so they take it from that point on. So their code is initialized, and then they can start to develop, not from zero, but they have a big head start. So this is a nice addition to our enablement process. Terraform Enterprise, at the heart of infrastructure as code. So when we deploy this product, it is linked to that repository. We onboard the users, so we give them permission so that they can go into the Terraform Enterprise and to trigger their plans and applies. And we scope their workspace to their project that they requested. And so we ensure that they have access only to their workspace, and that workspace can manage their project and the services they requested, the compliant services. Finally, Vault. So we've heard a lot about Vault today, and Vault definitely comes into play. We're heavy users of it. So we configure Vault and Vault policy, static accounts on there, which are all linked together, so that only this workspace can use the static account, which is in the secret engine, and which is scoped to their project. So this is kind of gluing everything together. So at the end of the day, this product is a logical linking of multiple providers into something powerful. And this is infrastructure as code enablement for developers. And it has been very successful for us. There's a high level of abstraction. So our developers are just saying, this identifies my workload. These are the services. What do I want my repo to be called? It's not complicated, and you get that. And it's also extensible. So we can add more pillars to this. We're already looking at adding Grafana Cloud into here. So based on those 6 services, you could say, hey, I want dashboards for them. I want some standard alerting. So I have observability then baked into my environment as well. And we can add more and more as we have more ideas as well. So definitely been a very successful approach for us. So in the end, we're jump-starting our developer experience. We're providing speed and agility, so empowering our developer teams in GCP to be independent, not reliant on central infrastructure teams. And in the end, they set the pace. They say, I want a new cloud resource, I want it today, they can have it today. They can do it. It is up to them. If they want it next week, they can deploy it. And this is really important for them to become independent, to meet the speed so that we can onboard more workloads and unlock more value from the cloud. And the built-in compliance and security, of course, is a non-negotiable for us, and it's baked into this product. It's baked into how we work, how they all work as well. And I'm very certain none of them actually even know HashiCorp Vault exists. It's a very important piece of the puzzle, but it's kind of this thing of no news is good news, but it just works. They trigger a run on Terraform Enterprise, and yeah, it authenticates somehow, and they're happy. The other great benefit of this is it frees actually us up as a developer team, or landing zone team, to provide more innovation, to improve the onboarding process, and ultimately make the life of developers better, because we're letting them take ownership of their part, and we can empower them even more and more. So the last piece of the puzzle. So getting to this point, it was important for us to have close collaboration with our partners. So HashiCorp and FullStacks were very important to helping us to establish our automation framework. So this was very good for us. So have a chat with the FullStacks guys. They have the booth over there. So over the last 3 years since we started working with them, it's been quite successful. GCP we've had very good close collaboration with, and one thing I would say with GCP is they have some very good resources for Terraform. They really seem to favor Terraform as a way to manage infrastructure, and they have some great modules out there. They had some resources that really saved us months of effort, and we contribute actually to some of their public resources as well. So Terraform community extends, it's coming within Erste Digital, but it also extends outside.